All right. In this video, we're gonna focus on calculation on electrostatic force. Of course, we have introduced this topic where I explain what electrostatics is and what electrostatic force is. Please take note. Okay. So this is the third question here under electrostatic force. So let's understand the question carefully before we solve this question. We are asked here to find the magnitude of the electrostatic force, that is this of attraction, okay, between an alpha and electron. So the distance apart here is said to be this is distance apart here. So we have to understand what alpha particle is in terms of charge, and we have to understand what electron is in terms of charge. But in case you have not subscribed to this YouTube channel, kindly hit the subscribe button in order to watch the full video in electrostatic force. We have done the introduction of electrostatic force. We have solved some questions. That is question 1 and question 2. This is our question 3 here. So to watch the full video on electrostatic force, kindly hit the subscribe button. Okay, now let's try to focus on this. Okay, solution. Let's solve this, please. Okay, now solving this here, this is what we should understand, that we are asked to find the force between two charges, and the charge here represented in this question here is to be alpha charge and then electron charge. So in terms of charge, that is Q1 is given to us as an alpha particle. That is Q1 is said to be alpha, and an alpha particle emits the charge of 2 electron positive. Please take note. An alpha particle emits the charge of 2 electron positive. So an electron, that is the second charge, which is said to be Q2, is said to be electron, that is negative. So an electron is a charge, but a negative charge. But take note of this here, that E has a numerical value. The value of E, please take note, the value of E is said to be, the numerical value of E is said to be 1.6 times 10 to the power of minus 19 coulombs. Please take note. The value of E is said to be 1.6 times 10 to the power minus 19 coulombs. That means anywhere we see E in this particular point here, we have to replace our E to be 1.6 times 10 to the power minus 19 coulombs. While this is said to be also 1.6 times 10 to the power minus 19 coulombs, but in terms of this electron here, we replace this to be minus because of the electron charge. Okay, so now let's try to replace why the distance apart, which is said to be, the arrow is said to be giving us 10 to the power of minus 13 meters. Okay, but remember that in calculating the force between two charges, we apply Coulomb's law. Whenever we are asked to calculate the force between two charges, we apply Coulomb's law. So applying Coulomb's law here, we state that F is equal to K Q1 Q2 over R squared. Please take note, where our K has a numerical value which is said to be 9 times 10 to the power of 9 Newton meter square per coulomb square, while the expression of K is said to be 1 over 4 pi epsilon naught. That means this guy here, please take note of this, can also give us this particular value here. Okay, when you replace the value of pi, replace the value of the epsilon. Okay, so now let's try to impute the values in this question here into the formula to get our answer. So imputing the value here, that means this is going to be F is equal to, K is said to be 9 times 10 raised to the power of 9 times Q1 is already given to us as 2 times 1.6 times 10 raised to the power of minus 19 times Q2 is said to be minus 1.6 times 10 raised to the power of minus 19, please take note, over 10 raised to the power of minus 13 square, please take note. So replacing this here, punching your calculator here, that means our final answer here for F is going to be, let's get our final answer here. Our final answer here, when you punch your calculator, that is this here, this times this times this times this. Okay, we are going to have minus something, and this one here, remember this is minus 13 times 2, using the law of indices, that if I have a raised to the power of m or raised to the power of n, the answer is going to be a raised to the power of mn, meaning that this power will times this power. So this power minus 13 times 2 will give us minus 26. So when you punch your calculator, our answer is said to be 0.046 Newton. So this is our answer here. Of course, there's minus here, and this minus here is said to be the force of attraction. This minus indicates that this force, the nature of the force, is said to be force of attraction. Or you can write this to be F is equal to 0.046 in newtons into attractive. So this word attractive here means that there is minus at the front of this and F here, that is this force here, please take note. So why is it minus? Why is it attractive? Why is it going to be repulsive? When is force said to be attractive? When is the force said to be repulsive? Now this is what you should understand here very clearly, that to know the nature of the force is always determined from the charge. So if the charge is repulsive, the force will be repulsive. If the charge is attractive, the force will be attractive, because the force is directly proportional to the charge from this Coulomb's law. The force is directly proportional to the charge here. So anything that happened to this charge here will also happen to this force here. So if the charge is attractive, okay, the force will be attractive. If the charge is repulsive, the force will be repulsive. Okay, now all you have to do here in order to get the full video is to hit this subscribe button to get the full video here. Thank you.